Hi everyone, my name is Jack Wagner. I am the president of the Artificial Intelligence Club. And Mir, do you want to introduce yourself?
Yeah, hi everyone. My name is Mir. I'm the technical coordinator for the Artificial Intelligence Club at Dearborn.
Yeah. So originally we did this first workshop on what is AI. However, we had some recording issues, so we're just re-recording it now. So for those of you that missed this workshop, you're able to see about what we talked about. This is actually a pretty important workshop in that we basically discussed, as you can see on the screen, what is AI. And more importantly, what it actually is compared to what people think it is. Talking about its general applications and just a high level view of what artificial intelligence is and what it means for current technological landscape. So, yeah, let's go ahead and begin.
All right, so moving to the first slide. This is understanding artificial intelligence for everyone. Jack, you want to go ahead?
Yep. Yeah, so in case you don't know about what the AI4ALL program is, we're basically focused on presenting AI to, well, you, and more specifically AI to all. What that essentially means is that when a lot of student organizations and a lot of groups out there talk about artificial intelligence, they tend to just keep it within the technological realm, not really focusing on what it actually means for people on a day-by-day basis, what AI technically is for those who don't have computer science backgrounds and just overall like its impact on the world. So that's kind of the focus on our program is to focus on the interdisciplinary applications of artificial intelligence and showing beyond just the technical field and just opening up a integrative development environment how AI is actually impacting you. I'm sure you, the viewers at home, have a lot of questions about what AI is, so hopefully by the end of this presentation that will help you guys understand. So, Amir, do you want to go to the next slide?
Mhm. Okay, so let's give this as an icebreaker poll we did as part of the original presentation. Getting feedback and asking people what AI actually is, or like what they think AI actually is. So let's just move on from this.
Yeah. A lot of people thought it
And
was just like robots, things that'll take your job, but you're about to understand immediately that AI isn't exactly what you may think it is. And that leads into the first point of automation versus intelligence. So yeah, so AI itself is considered the simulation of human intelligence processes by computer programs. What that essentially means is that when we think about artificial intelligence, we're trying to train all these algorithms and things to basically understand how a human works. When you look at ChatGPT and all these different conversational chatbots, for instance, that you may have used in your daily life, you notice that the responses try to sound human but aren't exactly there. That's because it's trying to simulate human behavior through just these conversational aspects. So when I ask ChatGPT, um, where's the nearest doctor, for instance, it's not going to exactly know where uh, a doctor's office is for me in the same veins that Google Maps is, because it's kind of just trained on how to react in those situations, rather than understanding where it can look for that information. It may try to give you an answer, but as you may know, AI chatbots don't give you the correct information all the time. I'm sure if you've asked it about historical events, it's giving you wrong dates, wrong articles and events that have happened, or just completely made up things on its own. That's where hallucinations come in. But that's essentially like what the definition of AI is, and that it's a simulation of human intelligence. And there's really two key distinctions that people need to make when it comes to AI, that being automation and intelligence itself. So, automation, you can kind of see on the left of the slide, that's performing tasks without human intervention. So, typically, when we think about warehouses, there's typically just like automated machines that basically take a task and do it on its own from point A to point B. And automation itself is kind of just that. Basically, a routine going from point A to point B in order to basically derive some kind of result. You've probably heard of something called an automation script. That essentially just means the script itself was made to take in some kind of input, do some kind of operations, and give you an output. So, for instance, auto graders, perhaps, maybe you've seen that on Canvas, where once you basically put in all your answers, it hits submit. The auto grader will go through all of your answers, check to see if they're correct, and then based on what you got correct, it'll output some kind of score at the end so you know how you did, like on the Canvas quiz or anything like that. That's essentially an automated task. There's no intelligent systems involved in which it's trying to reason or anything like that. It's just going from point A to point B. It has a singular task that it does and just gives you the results based on that. Intelligence itself is kind of what we think about with AI specifically. This is where there is understanding, reasoning, learning, and adapting. Um, Again, with the conversational chatbots like ChatGPT and Gemini and all of that, um, that's basically where these kind of things lie upon. Where essentially with intelligence, it's trying to understand what you're saying, and then through its architecture, is trying to reason with itself what is the best response I can give this user, kind of like how a human does, albeit we'll kind of go over how ChatGPT isn't really that human-like as you may think. Um, but yeah, essentially when we think of artificial intelligence itself, these two are just kind of distinctions between what AI is. But as we'll see on this next slide here, you're going to learn very quickly that AI itself is really just algorithms. This is a common term that you've probably heard within computer science. You've probably even heard about that in general with AI, there's a lot of buzzwords out there with artificial intelligence, and one of them is just saying, "Oh, the algorithm this, the algorithm that." If you're on social media sites, for instance, you probably hear people saying, "The algorithm recommended me this." But what does that exactly mean? So AI itself is built upon algorithms, but algorithms themselves are not AI. If you have no idea what an algorithm is and you're looking at the math on the screen, you're probably terrified. Don't worry, you don't need to understand this. All you need to know is that an algorithm itself, that's just a preset, rigid, coded recipe that gets executed when triggered. It's kind of like the automation example I said before. Basically, these algorithms wait for the action to come in. Once it figures it out, then it starts running whatever script it may be laying upon, and then it gets the output, and that's basically it. With algorithms, you've probably heard about them before, but essentially they just take in an input, do some operations, take an output. AI itself is taking all these algorithms and grouping them together in order to modify themselves and just create new algorithms and reasoning based on its learned inputs and data. That's basically what we typically call intelligence, is essentially um, the AI system itself reasoning upon its inputs and data and trying to make new algorithms and reasoning based on what it already has in store. If you ever heard of the term knowledge base, that's basically where when you're first making, maybe let's say, for example, you're making your own ChatGPT and a website. What a lot of people will do is acquire a knowledge base, which can just be a bunch of documents you want to train it on, put that into the chatbot itself, and then output it to whatever results you want it to be. Essentially, with this knowledge base, you're just basically telling what the chatbot needs to know in order to make its reasoning. So, if you're doing something related to a website, for instance, like you're doing a shopping website for clothes, you want to have a ChatGPT kind of agents in your website in order to help people basically have guidance towards what they want to buy. You could probably just put in like your catalog of what you're selling on the store, for instance. That can be an example of a knowledge base where you basically take all that information, give it to the chatbot, and it will be able to understand and reason with user input based on this. And so, as you can probably tell, all these AI algorithms and models are just built on probabilistic models and calculations to help make their predictions. Um, If you have taken statistics courses, you basically know that if you've heard of like Bayes' theorem or conditional probability, that's basically like a foundation for artificial intelligence. But all you really need to know is that these outputs that you're getting are based on probabilities themselves, and as a result, there is always the chance for hallucinations, answers not being right, because it's just trying to predict what the best output is. When you're kind of naively relying on Gemini or Grok or ChatGPT, you're basically kind of relying on, did I get the right output? It's kind of like playing the lottery, to be completely honest. So it's just interesting to think about how when people say ChatGPT is being like this knowledge source of all knowing, it's really just kind of thinking through like a human. Um, you probably have talked to your friends before who don't know a lot about certain subjects. That's kind of similar to ChatGPT, in which it kind of just gives you advice, essentially. It's not hard-coded facts, no matter how many resources it is. So when you're asking it to make research papers for you, for instance, it basically reasons like a human in order to get all these sources, put all these connections together and stuff like that. It's not guaranteed to be 100% right because, again, it's based off all these probabilities. So yeah. Then Mir, do you want to go to the next slide? And that kind of leads into another topic, weak versus strong AI. This is probably the most important distinction that you're going to get out of this workshop is knowing what these two are, how different they are, because these terms are thrown around and people think we're in the world of strong AI. That's just not true at all. As we can see right here with weak AI, we are currently in the presence of weak AI, and that's real and present within our lives. So, Mir, if you want to go to the next slide. Yeah. So weak AI itself is referring to systems that are designed and trained to perform a specific task. For instance, you probably heard about computer vision models. If you know what OpenCV is, that's basically what it is. A common project that people learn when they're trying to understand computer vision is facial recognition, where a system will look at your face and try to match it up with whatever it's trained on. Similar thing is language translation, Google Translate, and I think Apple Translate. I'm not sure what the new version's called with the Apple AirPods Pros 4. But essentially, those features are technically AI because it's using some kind of systematic learning in order to help understand how you can go from point A to point B. Um, And yeah, these types of systems are operated under a limited set of constraints, and they cannot function beyond their designated tasks. So when we talk about AI, with chatbots, for instance, I keep referencing that because it's an important thing to distinct, and also a lot of people use them every day. These chatbots, their only function is to basically talk to you, give you advice and stuff like that. So as a result, they're not going to function outside of these. They aren't trained to basically like become sentient robots, for instance, like people try to throw out there. These chatbots are essentially trained to just conversate with you. Same thing with email spam filters, self-driving cars, GPS and navigation, and autocorrect. All of these features that you kind of use on a day-by-day basis, they are AI, but they are a lot more basic than you think. With self-driving cars, for instance, their function is to drive on their own from point A to point B. They're not going to do anything outside of that. Same thing with GPS. They use AI methodologies in order to get you from point A to point B and show you the best routes, but they're not going to do anything outside of that. Autocorrect, it will fix whatever words that you have in your text that may not have been spelled correctly or maybe some kind of alliteration or whatever. They're not going to function outside of what it's told to do. Yeah. And then with the next slide, that is a concept that a lot of people try to think about is strong AI. Um, People think that we're in this phase of strong AI, and We're reaching it a tiny bit, but we're so early on into AI development than people think that we're now actually reaching this realm. So, what exactly is strong AI? Well, for one, it's a theoretical concept, but two, it basically represents a type of artificial intelligence that possesses the ability to understand, learn, and apply knowledge across a wide range of tasks, much like a human. This is essentially the closest thing to a computer being sentient and trying to act human-like. Um, the problem is it's so advanced that we're not actually there yet. Sure, you see stuff like GPT 4/5 passing the bar exam or understanding images, or Google DeepMind's Mu Zero, which is essentially this project by Google DeepMind to basically master unknown video games via brute force. You've heard about chess bots, you've heard about bots that play Go and stuff like that. They are based on like applied learned behaviors, algorithms, all these things. This Mu Zero project basically is focusing on how do I learn a video game like Pac-Man, Space Invaders, Donkey Kong, all these old 80s arcade games that many people have grown up with. How does it learn to play them on their own and win every single time? The key trick to it is actually just brute force. What that means is it will just try different routes on every single possibility until it loses or wins. It records all that and then helps try to determine what is the best output to win given every single scenario it knows. If you know games like Pac-Man and Donkey Kong, especially Pac-Man, for instance, you know how complicated those games get fast. Tic-tac-toe is a common game that a lot of people try to learn with AI. There's a lot of popular algorithms like Minimax, for instance, which focus on how to understand AI thinking through tic-tac-toe because it has what we call a limited state space. You know, it's a 3 by 3 board. There's two possible moves. There is a lot of possibilities to win, lose, and tie, but it's still limited. We know the scope of it. Games like chess and Go, on the other hand, those get more complicated because you start thinking about all the different chess rules, all the different Go rules, and you realize immediately how difficult it's going to be. Um, Games like Pac-Man, those get into the exponential range. Same thing with Donkey Kong, Super Mario. All of these arcade games and all these old video games, they have so much complexity to them that it's hard for a machine to actually understand how to simulate winning these games, and that this Mu Zero project is going to take a long time. It's not going to be able to beat you in like Super Smash Bros. And Mario Kart immediately. It's going to take possibly decades, to be completely honest. There's so much computing power involved with it that it's hard to understand how long that's going to take. And same thing with GPT. I know there's like offshoot stories about ChatGPT maybe becoming sentient or something like that. It's such a rare case and also very hard to actually get that sort of edge case that it's not reasonable in a actual timeline in order to cause something like that. So we're very, very far away from this that people think. And people are countering stuff like super intelligence every day. So honestly, don't worry about stuff like strong AI taking your jobs. That is also another thing people worry about with this is that will AI take my job? Will strong AI take my job? Will weak AI take my job? Um, Strong AI theoretically could, but again, A, it's theoretical, and B, we're so far away that it's like we really don't know what it's actually going to be. With weak AI, your job should be secure. I know there's a lot of media buzz about people being laid off and being replaced by ChatGPT or Claude or Gemini. Quite honestly, like developers are going to realize immediately why that's a mistake because if you ever try to code with ChatGPT, you're going to realize how bad it actually is. Stuff like the databases being public, API keys being exposed, um, just a lot of issues come up immediately with something called vibe coding, which there are best practices for it, and you can still learn from it. But quite honestly, it's not good enough to just replace a whole human. So yeah, there's that. And I think next we're going to be talking about just a brief history of artificial intelligence as well. Yeah. So right here, this is just a really, really high level overview of different AI concepts. And we'll start in 1950 with Alan Turing. He is a very popular computer scientist who proposed the Turing test. So what the Turing test is essentially, and we can kind of see it on the picture in the 1950 section, which Mir, I think you can click on to zoom in. Yeah, there we go. Um, Basically, it's just a measure of general machine intelligence. When computers were first starting to be more fleshed out, we wanted to know what the limits of them were. And so, what this Turing test essentially did was have two human, two humans and one computer. One human would be an interrogator, the other human would be a human responder player, and then you'd have a computer be the other player. And as you can see in the diagram up here, basically the human interrogator will ask several questions to both the computer and the human responder. And based solely on the answers to those questions, the interrogator tries to determine which player is a computer and which player is a human respondent. Um, this game essentially kind of showed how we can try to get computers to be a bit more intelligent, and I'm sure you can do the same thing with ChatGPT nowadays, where you probably get a friend and try to do a similar game. I'm sure that because of how much advanced like GPT has become, for instance, you can definitely reenact this Turing test for yourself. And honestly, it's kind of a fun experiment, so I definitely recommend it. And then if we go to the next slide, yeah, and so in 1956, this is basically where the Dartmouth conference happened. Um, this is essentially where some of the greatest computer science minds of the world, you can recognize a few names already, Claude Shannon, Marvin Minsky, Nathaniel Rochester, Alan Newell, all these great minds essentially herald the birth of AI as a field of computer science. Before, we didn't really know what AI was, so these guys just kind of came together and defined a bunch of things like what exactly is natural language processing, what exactly is deep learning, what is the study of AI itself. Basically, defining all these different fields of artificial intelligence in order to essentially just give an idea for us to know how AI was going to progress in the future. Then if we move to the next slide, yeah, so in 1997, you probably saw this previously when we talked about weak AI. This was IBM's Deep Blue robot. This is basically a chess playing robot or a chess playing machine, excuse me. And basically, what scientists wanted to figure out was could a computer playing chess against a real person beat chess champions in order to show how strategic and intelligent that AI actually was. And so in 1997, IBM's Deep Blue machine essentially did this. They beat chess champion Garry Kasparov. They just played a game of chess. The human that you can see by the computer screen essentially um, put in all the moves or looked at what Gary was putting in as moves. Then the robot would try to determine what the best output would be, told the human to move it to that piece, and that's basically how they played out the game. And in this specific case, the robots basically beat a human. So, and chess champion at that. So, and I'm sure there's also current examples with Go, backgammon, probably a lot of other types of games like this where a machine could basically beat a human. But again, it's based on probabilities. It's still weak AI, so wasn't as advanced yet. And then the next slide. Yeah, so this next slide talked about the rise in deep learning. Basically, in 2012, we had the concept called AlexNet come to fruition. This is just one of many deep learning algorithms that basically led to a breakthrough in image and speech recognition. Um, Basically, in deep learning, they take all these layers of nodes, we call them, and basically put them through a bunch of operations in order to get an output. AlexNet right here basically introduced the concept of layering, putting in all these different layers from an image input to an output, and basically covered how these deep learning concepts were brought to fruition. Um, and yeah, and I think the last slide, yep, there we go. This last slide basically just says ChatGPT exists. Woo, yay. But generative AI itself basically became a lot more popular and prevalent in 2023. Um, Late 2022 is when like the first public version of ChatGPT came out, but since then we all know what kind of beast it's been. Basically been able to produce text, images, and music. Um, I don't really need to show examples here because I'm sure you've seen a bunch of them. And since then, we're kind of just in this modern age of AI where generative AI has kind of been the big talk of the town. But as we're about to see on the next couple of slides, we're going to understand immediately AI isn't just used for making funny images to put on Facebook. In fact, there's a lot of real world applications. So this first one here is basically just AI being used in the medical field. And so within healthcare medicine, AI can be used for predictive analysis, diagnostic assistance, and personalized treatment plans, which help with enhancing patient care and operational efficiency. You've probably heard in the news that AI has been able to basically look at an X-ray of someone and determine, yep, you have cancer like 5 years ahead of time. It's actually kind of insane how smart it is with this because it can basically help with diagnoses years before they're actually needed and help someone get the care that they actually need or be able to find something that a human probably overlooked. Um, yeah, it's a very big talk right now about how AI can be used in medicine just because, like I said, if it could detect cancer sooner than a human can, and we're able to crack like how it can do it every single time, that's pretty much a game changer in the healthcare world. And then for the next slide, we have AI in finance. So again, this is kind of a mix between AI algorithms and like automation itself, where basically these algorithms can analyze market trends, assess risks, and automate different trading processes, leading to more informed decision making and increased profitability. So again, as we know, the stock market is always changing, for instance. So based on the different changes that are going on, what you can do is basically set up an AI system to look at your portfolio, look at all these trends that are going on in the market, and basically figure out what would be the best investment option for me. Do I buy? Do I sell? Do I w basically wait to take any action until we reach a certain threshold? These systems can basically do that on their own. Next slide, we'll talk about AI and engineering. If you know what CAD is, that is a popular example. It's a bit more on the generative side, but AI itself can help with predictive maintenance, optimization algorithms, and different design simulations. All of these are basically helping to basically improve project outcomes and reduce costs since you're helping with optimizing different systems, doing predictive maintenance in order to look at different oversights in design. And you can also do different design simulations to kind of maybe simulate what happened if these certain factors affected what I'm currently creating and stuff like that. And then next slide. this talks about AI in the law field. So, um, yeah, there we go. Yeah, so AI can like anything else assist with legal research, contract analysis, and case prediction. Um, there's also some talk that AI lawyers are becoming a thing, but again, they're being based off precedents. If and also like these models, if there's new cases that are coming out and they want you to reference it, it's not going to be able to do that. Something interesting about chatbots as well is that these chatbots are able to essentially um, be trained on data up to a certain point, and anything past that, it will basically say, "Hey, I don't know anything past this point, but here's what I do know." So as a result, it can't really be updated with current cases, but it's basically kind of like a research bot where essentially it can assist with this type of research and contract analysis. Um, and basically allow you to just expedite your research as an attorney. Then next slide. Lastly, we have AI in the arts. So this is where generative AI is. So we have creating music, visual art, and assistance with writing scripts to expand the creative process. This comes with pros and cons. The pros just being that, obviously you can make these systems on your own, but the cons are really just basically it still comes from certain data. So all these chatbots and all these services like Dolly and Sora, if you've heard of those before, they're basically making all of their artwork and stuff based off of different resources in that. So it's not really coming up with it on its own. It's really just taking aspects of it and kind of throwing it all together. And this can lead to issues such as like personal issues, like your likeness could show up in one of these videos or images. There's also copyright issues where if it comes from copyrighted material, I believe like the founder Studio Ghibli recently sued because AI art was being used with their designs. There are issues with that and different pitfalls like that. I'm sure there's going to be like copyright law made in the next 5 years specifically talking about ChatGPT or about AI specific services. Um, but again, like there is the process for this. We know about Gen AI. We know that it's prevalent, but again, there's always pros and cons to using these types of services. Okay, and then next slide. Yeah, and so now Mir is just
Okay.
going to walk us through myths versus realities for AI.
All right. Welcome back, everyone. So now we're going to be going through this Kahoot. So as part of the original presentation that we did, we had everyone take this quiz where we would basically present different systems and ask people if those systems are run by AI or if they're not run by AI, based on what they think. So we'll be going through this kind of fast, and I will give an explanation for some of these different systems and how they're actually being run and like what is the logic behind them. So, okay, so is it AI? The first question is Spotify suggests new songs based on what you've listened to before. So is that an AI running or is it not an AI? Is it something else? So the correct answer to this question is yes. This is an AI. Uh, the reason for this is that Spotify's recommendation system is actually powered by machine learning algorithms, which analyzes your listening history. So, like what songs you've listened to, what songs you skipped, what songs you've replayed, things like that. And it compares it with like millions of other users' behaviors. And then what it does with that data is that it looks for patterns and like similarities to predict which songs you will probably enjoy next. So the more music you listen to, the more accurate this algorithm becomes because it keeps learning from your data. So it's a very dynamic, it's an adaptive system that evolves, like as the user uses it. So that's like an AI system. Um, so that's the answer for that. The next question is, you set your alarm for 7 a.m. and it brings at 7 a.m. basically an alarm clock. Is that AI or is it not an AI? So the answer to this clearly is false. This is not an AI system. The reason for this, while it may seem obvious, is that uh, when you set an alarm, you're actually giving the device a specific instruction, like at 7 a.m., play a sound. So the clock doesn't learn from your sleeping habits. It doesn't adapt to your schedule. It doesn't make any decisions. It just executes like a simple programmed rule that's been defined by you in advance. So the outcome never changes unless you manually change the input. So that's a very static system. There's no artificial intelligence or like dynamic learning or anything involved. Next question, Google Maps reroutes you in real time to avoid traffic. So is this an AI system or is this not an AI system? The answer to this is true. This is an AI system. The reason for this is Google Maps uses AI and predictive modeling to analyze like large amounts of live data from GPS, from road sensors, from satellites, from user reports, and it continuously updates the traffic flow. It detects congestion patterns. It calculates, the fastest possible routes based on all this data it's getting and all these different changing conditions. So this requires both data-driven reasoning, data-driven predictions, which are like some core fundamental, features of AI systems. So it's actively learning from like historical data from live data to optimize like to look at the traffic and based on that optimize the routing decisions that it presents to you. So the next question is Excel automatically adds numbers when you click AutoSum. So AutoSum in Excel is a rule-based automation. So like when you click a button, it runs a pre-written command that identifies a range of cells and it applies the sum, the addition function. So the answer to this based on that is false. This is not an AI system. Um, the reason for that is that there's no reasoning or learning involved from Excel here. Excel doesn't decide how to calculate something, based on any context. All it does is it executes a fixed, like a deterministic process, where it just adds up the numbers in a column. So it's an automation, but it's not, Jack covered the difference between automation and AI. So this is like a very core automation kind of feature, but it's not AI. So it helps you make repetitive tasks fast, but it follows a very static system, a static algorithm that never changes or evolves. So the next question is you type a question and get the full written response via ChatGPT. So, this is obviously ChatGPT. So this would be true. This is an AI system. So sort of the reasoning behind that is that ChatGPT is a large language model. It's been trained on like a lot of data, text data, to predict what word or what sentences should come next in a conversation. So it doesn't have ChatGPT doesn't come with any pre-written answers. It generates language dynamically based on the patterns that it's been taught, and it learns on its own. The process mimics like human reasoning, as Jack discussed very extensively during the presentation. So, like a human, it responds to different questions in unique ways, like context-aware ways. It knows the background behind every question. It's the definition of AI, I would say, because the system is capable of adapting to like new inputs, and producing, original outputs every time. So the next question is, you set your room to 72 degrees with a thermostat and it keeps that temperature. So the answer to this question is false. This is not an AI system. This is sort of a difficult question. And the reason this isn't an AI system is that a traditional thermostat uses something called a feedback control loop. So that like when the temperature drops below 72 degrees in this case, it turns the heat on. And when the temperature rises above 72 degrees, it turns it off. So that's automation. That's not AI. So it's reacting to like environmental changes using like predefined thresholds, but it's not learning from any new data. It's not learning from the temperature. All the only data it's looking at is what the temperature is. If the temperature is this, it's going to turn on. If the temperature is not this, it's going to turn off. So That's a very simple thermostat. Now, there are like smart thermostats, like Google's Nest thermostat, that would use AI actually by analyzing your habits, and then dynamically adjusting the temperature based on, like how often you're in the house, um, when you go to sleep, things like that. I mean, it takes in so many things into consideration to automatically like keep updating the temperature based on your behavior and your patterns and like other factors as well. Um, but this basic thermostat in this case simply executes like a fixed, just basically a rule without any adaptation or any prediction or anything. So next question, your phone recognizes your face to unlock. So this is true. This is an AI system. So like Face ID in iPhones, that would be like an AI feature. Reason for this is that facial recognition relies on like computer vision models that are trained with machine learning. Um, So the system would learn what your face looks like by mapping like key values, key features on your face, such as like the distance between your eyes, the shape of your jawline, the shape of your nose, how light is reflecting off your skin. It takes like a lot of these features into consideration, so that when you look at your phone, it analyzes the image that it's been taught, it extracts the patterns, it looks at your face, when you are turning on the phone, when you're looking at the phone, and it basically compares your face with what it's the picture that it originally has. And it's sort of comparing those features that it learned and it's seeing if they match. Um, uh, and then over time, this becomes more robust to different lighting, different angles, and even if like your appearance changes slightly, every time you unlock your phone, it is like dynamically learning it, like from your features, so that it becomes more and more accurate over time. So that's why it would be AI is like always actively learning. It's not like an automation. It's not a static system. Um, Final question. You click auto enhance on Photoshop and the picture brightens. Um, so what auto enhance does in Photoshop, it applies a preset series of edits to a photo, such as like adjusting the brightness, the contrast, the sharpness in an image, but that's based on predefined parameters. So in this case, the answer here would be true. Um, the reason for that is it doesn't learn your personal editing style or improve based on feedback. So every click produces the same type of enhancement regardless of the user. So now, although Adobe offers AI-powered tools, the classic auto enhance function is a like a static AI feature, but it doesn't actively learn. So it's not like AI to the degree that some other systems in here are. But it is learning. So like recently, Adobe has released updates to Auto Enhance where it does learn, um, different things like as you use Photoshop more and more, um, and it adjusts the settings in the photo based on that. But this was the last question. So this is the end of the presentation. So Jack, you want to take over from here?
So yeah, that was basically just a little wrap up that we did. So just to wrap up this session, as we reflect on basically everything we talked about, it's important to assess how the perspectives on AI have evolved. We did a little poll after all of these activities just to see like what was the difference you thought of AI before we started talking and then after. And then I think the next slide is just kind of a review of everything. Yeah. Yeah, so just three main takeaways to understand from this presentation. So the first one with AI's interdisciplinary impact. Understanding AI itself is crucial since it just impacts, obviously your fields that you maybe wanted to go into and career paths, not just computer science itself. We talked about five examples across law, the arts, finance, medicine, and many more, just to kind of give you an idea of some of the ways AI is impacting us. But again, excuse me, there are way more examples of this. Like in engineering, I know we talked about like using it in CAD models and optimization algorithms, but there could be more ways of doing it, like robots to basically do everything and stuff like that. And then, as a reminder, we're currently in the age of weak AI. This is where your chatbots and your navigation tools are currently. We are not in strong AI. That's the hypothetical concept that AI can be what humans are currently. And just remembering this distinction will help you realistically achieve or realistically understand what AI can achieve currently. And then lastly, as Mir put it through our little Kahoot, we basically showed you what is AI, what isn't. Google Maps and ChatGPT have AI functionalities, but some may be less involved with AI than others. So again, there are AI features out there. We talked about with Spotify recommending stuff to you, Google Maps showing you GPS. Um, Always remember that like when we talk about AI and stuff like that, in these cases, these aren't the things that like, take your data, use it for malicious use, based on your inputs or anything like that. All these are doing is just kind of giving you a better experience as a user in order to keep using their services. So again, this isn't one of those things where it's like your privacy is being uh, disturbed by these companies in order to use it for their training data. This is really just these services exist in order to help you as a user just continue to grow. Your autocorrect on your phone, for instance, will help you text better, or your email spam filters will make sure that your inbox isn't flooded with just random scams and random people just trying to message you for no reason. So again, just remembering these types of basic distinctions that we talked about today will really help you understand where the future of AI is heading. So that basically concludes the first AI for All workshop. Thank you for watching, and we hope to see you at one of our workshops soon in the future.